Consider the following CPU processes with arrival times in milliseconds and length of CPU bursts in milliseconds given below. There are 4 processes and their arrival times and burst times are given here. If the preemptive shortest remaining time first scheduling algorithm is used to schedule the process, then the average waiting time across all processes is dash milliseconds. So this is a question from operating systems regarding process scheduling. They have given preemptive shortest remaining time first scheduling algorithm and they are asking us to find what would be the average waiting time for all these processes. So let us draw this. So for each time quantum, let us see what happens. The arrival times of each process I have given here, P1, P2, P3, P4. So let us see how it proceeds. So initially we have only P1 here. So we'll start running P1. After reaching 3, we'll see that P2 also has arrived. Now P1 has run for 3 milliseconds. There's a total burst time of 7 milliseconds. So the remaining is 4 milliseconds in P1 currently. Now P2 is also there. P2 has only 3 milliseconds remaining, which means according to the shortest remaining time first algorithm, P2 will be chosen to run now. There will be a context switch and P2 will be chosen since it's a preemptive shortest remaining time first algorithm. So we'll start running P2 here. After 2 time quantum, we'll see that the process P3 arrives. P3 has 5 milliseconds, but P2 currently has only 1 millisecond remaining. It has already run, total was 3, so only 1 millisecond is remaining. So we'll keep on running P2. It will run for 1 more time quantum and P2 will be over by now. And by this time P4 also would have arrived. So we have 4 milliseconds remaining in P1, 5 milliseconds remaining in P3 and 2 milliseconds remaining in P4. So the shortest remaining time first algorithm will choose P4 now. So P4 will run for 2 time quantum and then it is over. From the rest, P1 has 4, P3 has 5. So P1 will be chosen. P1 will run for 4 more time quantum and P1 will be over, and then P3 will run for 5 more time quantum. So we'll find out the average wait time. So for P1 arrived at 0 and P1 got over at 12. Out of that, for 7 time quantum, it was the burst time of P1. So the waiting time of P1 is this, the completion time, this is the arrival time. And this is the burst time. And waiting time is completion time minus arrival time, the whole minus burst time, that is 12 minus 0 minus 7, which is 5. Similarly, P2 was over at 6, it arrived at 3 and it had 3 time quantum as burst. So the total waiting time is 6 minus 3 equals 0. Similarly for P3 was completed at 17, it arrived at 5 and it had 5 milliseconds burst time. So the total waiting time is 17 minus 5 which is 7. For P4 it is 8 minus 6 minus 2 equals 0, which we did similarly. So the waiting time for the average waiting time for the 4 processes is 5 plus 0 plus 7 plus 0 by 4, which is 12 by 4 equals 3.